In this lecture series today we're going to see the topic is big. It comes under the unit 4. We have the in the big data analytics in the introduction to map reduce programming and hive. It's in this topic we're going to see the how the big how it's important for big data analytics, how it will handle the huge volume of database, and more things in this lecture series. First, we have why we are going to see this kind of big topic comes under the big data analytics. The students we can able to learn more things in the big data analytics. With the help of big, we can easily handle the huge volume of data and easily process that kind of data. So here people find more difficulty to write program in Java, right? So for example, with the help of map, reduce, shuffle and sort, this kind of things help to reduce the difficulties in Java, writing Java program. Faster development, few lines of codes, writing map reduce like writing SQL queries, and reuse of the code, pick library, picky bank, kind of things. So find the top here. We can given the top 5 words with the most high frequency. The 10 lines of pick Latin versus 200 lines of Java. So here the 10 lines of pick Latin will equal to the similar 200 or more than 200 lines of Java programming. So compared to the Java, plenty of lines of programming with a single lines will help the reduce the codes. So 15 minutes in Big Latin will be also comparing the 4 hours of Java program. So comparatively, there are 10 to 20 times the time will be reduced compared to the Java comparing with the Big Latin. Here the next thing is we come here to introduction part of PIC. So it is PIC is developed by the Yahoo. It is analyze the data program without Java code. For non-programmers, it can be helped, right? So here we can have the use of simple steps. How the PIC can be used. Uses SQL queries by using the structure query languages. We can have the PIC in the big data analytics. The PIC first developed initially by the Yahoo, right? So here the next thing is PIC is an abstract over Hadoop. Here the framework for analyzing large unstructured, semi-structured data on the Hadoop. It is mainly for handling the analyzing the structured data, the unstructured data and semi-structured data on the top of the Hadoop. We already in the lecture series we are seeing how the Hadoop ecosystem, what are the Hadoop system. We given the brief explanation about the Hadoop in the previous lecture series videos. Here continue to that PIC, we can perform all kind of data manipulation operations in Hadoop using this PIC concept. So the PIC Latin is a declarative and is a structured query like languages. It is one of the higher languages. Interface, it acts as interface for the Hadoop and the database. PIC architecture has two major components: the PIC Latin and runtime environment. This is the main two architecture, mainly two components present in the architecture: PIC Latin and runtime environment. We can see, let's see the what is PIC architecture. Already we have seen the two main components: the map reduce and the PIC Latin scripts. In the PIC Latin scripts, we can have a grunt cell and a PIC server, and then parser, optimizer, compiler, execution engine, map reduce. Here the Hadoop is HDFS have Apache PIC architecture. We can have the Hadoop system. In this PIC architecture, we can see the two components. What are the two components present in this architecture? We can able to see in this PIC architecture. Mainly connected with the Apache PIC architecture. Apache is a kind of software tool used in the PIC to do the entire process in the big data analytics. By the help of Apache tool, we can implement these PIC concepts in for handling the large volume of data. Here PIC logical structure. We can have the PIC Latin and logical plan. A is a load. We can able to see in this PPT. We can have A, B, C, D, F up to load how the file 1 and file 2 as XYZ and TUV. They filtered by the join, then group by, then F is a forge of generate, and then it is a PIC Latin code, sample code we are given. The logical plan in the right side column we given as the load, filter, load, and etc. join group and other things we can have. So for example, for hatch we can have the store, then group content, then other things we can having in the logical big logical structure. Then example word, for example, the previous things in the logical structure we can lines equal to load, the words equal to for act, then flatten, and the groups and the counts and the results equal to ordered by words count. These are the some example word count given in the screen. We can store the top 5 into output and the top 5 words. The results can be ordered by words by counts. We can have discrimination. Then graphs equal to group words by word, and other thing is generated by things. So these are the some example word count we can have. Then accessing pick, next thing we are going to move about how we can accessing the pick is accessing easily accessible approaches. The first approach thing is a batch mode, as a submit as a script directly, and interactive mode, then ground the pick server Java class JDBC like interfaces. Then execution mode, we can have the local mode and map reduce mode. We can have the execution mode in the two things, local mode and map reduce mode. Like here we can have this accessing kind of pick. Comparing a big with already database is a first point is a pick is a data flow programming language. The declarative programming language is a general database we can have. Comparison between the pick, we can define a schema at a runtime, but it is an optional only. It will operate on any source of tuples. Compared to the database, we can have store data in tables with tightly predefined schemas. So that is the comparison between pick and database. Supports, it will support the complex nested data and structures. Then supports flatter and data structures. Then all writes are bulk streaming writes, low latency queries like transaction and indexes, and it supports low latency queries. So this is a major comparison between pick and other databases. We can have the how the data types we can using here. So this is a scalar type and a complex types, fields, tuple, back release. A field is a scalar type is int. Generally we what are the data types available in the C, the int, float, long, double, boolean, null, char, byte, and other things. Complex types is field tuples that we can have the field is a piece of data and tuple is an order set of fields, and the back is a collection of tuples and relation is a back. So these kind of things we can have the data types. And other pick operation we have loading the data, and after that projection and grouping and dump store and then aggregation. So these are the some what are the operations we are listed here to understand how the operations in the pick we are using. So pick Latin structure is a high level data processing. We are coming to the conclusion. There is a pick Latin structure is a high level data processing. It consists of collection of statements. Statements can be a more on the operation. For example, a group operation is a type of statement. Group records is a group records equal to by year we can have. So these kind of things we can seen in the big Latin structure. So this is about the pick and hive. In the unit 4 we are discussing in the lecture series basic concepts of pick, how the Apache pick tool using the pick implementing the pick concepts in the big data analytics, analyzing the structured data, semi-structured data, and other things we can having. Okay, so up to that we have seen the plenty of concepts in the under the pick in the big data analytics. Thank you for watching. Thank you.